Hello, in this lesson, we're gonna start talking about trigonometric functions. First of all, I'd like to recap on the definition of function. A function is a rule that assigns to each input, okay, each input in the domain exactly one output f of x in the range. So that's the definition of function. Trig function, however, is a complicated function, okay, because it requires some stage set, right? So that it requires some stage set before we can introduce the function. So let's look at the stage set. The first thing first, right? We need to understand, all six functions, sine, cosine, tangent, cotangent, secant, cosecant, they are all functions and it takes input, okay? It takes input, and this input could be an input for sine, okay? Input for sine, for example, okay? Or it could be any one of these functions, okay? So let me just put a, let's just say one column, 6, right? All six functions, sine, right? Sine take sine rule, the rule of sine, cosine, the rule of cosine, tangent, right? The rule of tangent, cotangent, the rule of cotangent, cosecant, and secant. Okay, all of these functions, they're going to take input. The inputs are angles. Okay, so these are angles. Angle, okay, it's just an angle. This angle, we have to talk about how this angle is measured. Okay, this angle is measured from something called standard position. So what is standard position? Okay, what is standard position? Standard position, okay, I'm going to draw a graph for you, right? The standard position is a position very specifically and consistently in the stage set. Okay, so let me draw that standard position for you. Okay, right here. Okay, standard position, right? Where do we start to measure angles, right? And we measure from a standard position, and that standard position is going to be this line. Okay, so I'm going to make it red. And this line is called the standard position. I'll make it thick. So you can see. Okay, this position is called a standard position, and we measure angle from this position. It could be going counterclockwise or clockwise. So this is called a standard position. Any angle is measured from the standard position. That angle can be the input. Okay, can be the input. Let me put it right here so we can see both, right? Every angle that's input for any one of these functions are angle measured from the standard position. So that's our input. Okay, and we will talk about domain range for the individual functions afterwards. Okay, so every angle is measured from that standard position. So, and there are rules about angle measurement. So the first rule is about angle measurement. The first rule is about angle measurement. So I'm going to call it A. Okay, so all inputs, okay, to the 6 trig functions are measured from the standard position. Okay, and that standard position basically is the positive direction of x-axis. Now, it comes to the first letter, the first important letter about trigonometry, we call it A. A is about angle measurement. Angle measurement, what does that mean, right? If the angle is measured from the standard position, of course, counterclockwise, and that angle will be called a positive angle. If the angle is measured from clockwise, and that will be called a negative angle. Okay, so positive angle, positive sign, okay, are for angles measured counterclockwise. Okay, negative angle, okay, positive angle, negative angle. Negative angle are for angles measured clockwise, are for angles clockwise. Okay, clockwise. So this is the first important rules on the stage set, about before we introduce trig functions, about angle measurement. Okay, so if we measure, say, if we measure, say, 45 degree, right? 45 degree counterclockwise, 45 degree, right? And there's a terminal. There's a terminal to that angle. We measure from standard position, and this is the angle, right? This is the angle 45 degree, 45 degree. Okay, which is right here. And this standard position is called the initial side, and this side is called terminal. Okay, so this is called terminal side. Terminal side. Okay, so another way we measure, right? Say we're going to measure clockwise. Okay, suppose I'm measuring an angle clockwise, and this angle will be terminating right here. Okay, if this happens to be 60 degree because it's measured clockwise, so we're gonna call this negative 60 degree. Okay, negative 60 degrees. Okay, negative 60 degrees. Let me rewrite that degrees. Okay, right here. So the sign in front of the angles measured from the standard position tell us how the angles are measured. Okay, so this is the first important concept in trigonometric functions. Okay, standard position, angle measurement. What else is important? Okay, what else is important? The next important thing is about reference angle. Reference angle. Okay, so it's our R. R stands for reference angle. Reference angle. Okay, so let me clean this up. What is a reference angle? Reference angle, okay, there's a definition. Reference angle is the positive acute angle between the terminal and x-axis. X-axis. Positive acute angle. Positive means it's positive, right? We're not going to care about negative. We're not going to care about direction. Acute angle. Acute angle means between 0 and 90 degrees. Okay. positive acute angle between, it's basically the angle between 0 to 90 degrees between the terminal and the x-axis. Between terminal and the x-axis. All right, for example, suppose I measure an angle. Okay, of course, from the standard position, right? In the first, right, if I measure this angle over here, right, it terminates. And the terminal is right here. Suppose this angle is say 50 degrees, right? It doesn't have to be one of those special angles, 50 degrees. And between the terminal and the x-axis, right? The positive acute angle between terminal and the x-axis, and here is the 50 degree itself. So this angle 50 degree is also the reference angle for the 50 degree angle we just measured. Okay, let's look at another example. Let's look at another example. Suppose I measure another angle over here, right? Counterclockwise. And the terminal is right here. Suppose this angle is, say, 140 degrees. It doesn't look like 140 degree. Let me make a better estimate, right? Say make it 160 degree. How about that? Okay, I'm just going to give an example. 160 degrees, right? And between the terminal and the x-axis, right? Terminal and the x-axis, there are two angles. So one is here is 160 degree, and the other one is this guy. The positive acute angle between terminal and x-axis, for that criteria, we only have this piece, okay, this piece between the terminal and x-axis. And of course, this angle is 20 degrees. 20 degrees. And the 20 degree is the reference angle for the 160 degree angle. Okay, so 20 degree is the reference angle for 160 degree angle. Okay, another example. Suppose I measure from the standard position clockwise, okay, and my terminal is right here, and my angle has a terminal. This terminal is right here. Suppose this angle, okay, suppose this angle is, of course, is a negative angle because it's measured is measured clockwise. So this angle is going to be negative 145 degrees. Okay, just for an example, 145 degrees. And what will be the reference angle for this negative 145 degrees? Well, it's going to be the terminal, between the terminal and the x-axis. So that angle has to be this guy. Okay, so this guy is the reference angle. And this reference angle, of course, is 180 degree minus 145 degree, right? And that's going to be 35 degrees. 35 degrees. All the reference angles are between 0 and 90 degrees. Between 0 and 90 degrees. And 35 degree plus 45 degree, that makes 180 degree. So the negative 145 degree, its reference angle is 35 degree. One more example. Okay, suppose I measure another angle clockwise. Okay, I measure another angle clockwise. And this angle, because I measure clockwise, okay, let me clean this up, right? Okay, make sure you take the notes, okay? If you need to watch it again, let me clean this up, okay? Clean up. So suppose I measure another angle, okay? clockwise, right here. And the terminal is right here. Suppose this angle, okay, suppose this angle is negative 50 degree. What is the reference angle for this negative 50 degree? Negative 50 degree because it's measured clockwise, right? What would be the reference angle between the terminal and the x-axis, right? The positive acute angle between terminal and x-axis. And the reference angle for negative 50 degree is going to be 50 degrees. Okay, so this is the definition of reference angle. Okay, and next we're ready to introduce our definition. We're ready to introduce our definition. Okay, so be sure you get the stage set. You get the stage set. Okay, so let's repeat the stage set. The stage set. Okay, number one, standard position. Number two, angle measurement. Angle measurement. Positive angle are measured counterclockwise from the standard position, and negative angle are measured clockwise, right, from the standard position. Okay, both are measured from the standard position, and we know what is the standard position. Okay, next, reference angle. Reference angle is the positive acute angle between the terminal and the x-axis. Okay, remember this definition. Now, finally, we get to introduce our definition. Okay, we have not introduced our definition. We merely talk about the input, right? What kind of quantity is our input? The definition of trig function are here. Okay, the definition of the function of the trig function is right here. Okay, so I'm going to bring the definition right here. So this is the D definition. Okay, definition says if A is an angle in standard position, it's measured in standard from the standard position, and the point x comma y on the terminal side of A other than the origin. What does that mean? Okay, the point x comma y. This point is actually arbitrarily chosen, right? So we have the standard position. Okay, we measure our angle and we have a terminal. We have a terminal. So for example, the terminal might be here. And the point xy, which we just pointed, can be anywhere on the terminal as long as it is not on the origin. Cannot be on the origin. Any point, okay? It can be any point. Of course, you just have to choose one. And this point has a coordinate, okay, ordered pair, x comma y. What is x? Right, what is x? X is the horizontal measure, okay? X is the horizontal measure. This is x, okay? And what is y? Y is a vertical measure. Okay, y is a vertical measure, or however you have, whatever color you use, okay? X is the distance between the point to y-axis, right? This is x, oops. Remove that to be consistent with the color, right? So x, this is x, right? So this is right, this is a, these two blues are the same height, are the same length, that's x, and that's y, right? And you can see x, y could be in different quadrant, right? So suppose we pick up a point for an angle, okay, okay? So now let's move down. I'm going to make it just a little bit smaller so we can fit in what we need to fit in. Okay, so we're going to introduce the definition. We're going to introduce the definition, right? A point, okay, a point on the terminal, right? It didn't say which point on the terminal. As long as the point is not on the origin, other than the origin, right? So we basically can choose any point. We can choose any point, okay, on the terminal. And that point has a coordinates. The terminal, any point. And this point has a coordinates, x, y. You know what x, y means, right? You know what x, y means. Now, since we have an x, we have a y, right? We have an x, we have a y. Suppose this is x, right? I'm going to use this as the x. This is x, right? And that is the y. Okay, so let's mark it. This is x. Let me get the color right. Okay, the blue color is x. Okay, the red color is y. Okay. Once we've done that, we see this is a right triangle, right? Right triangle with two legs. And this is hypotenuse. This is hypotenuse. And this hypotenuse can be found by using Pythagorean theorem, right? You can see this is R. R is right here, right? R is right here. This is R. Now we got the R, right? R can be found by rectangular Pythagorean theorem. Once we get the R, now we can decide, we can introduce the definition of trig functions. Now we're going to introduce the definition of trig functions. Okay, so sine of the angle, okay, the angle right here, okay, in fact, this angle is not unique. Okay, this angle is not unique. You could measure counterclockwise, and you could measure counterclockwise, clockwise, and you go around and around many sides. So this angle is not unique. Suppose we choose one of these angles, right? So you measure the angle, okay? So for this angle we have chosen, okay, and that's RA. Okay, this is RA. Okay, you can see the input for the function is the angle, and on the terminal of this angle, we pick arbitrarily a point x, y, and we're going to take, okay, now we have all the quantities we need. Sine is going to be y over r. Okay, and the cosine is going to be x over r. All right. And tangent is y over x. Cotangent are x over y. Notice this is actually different from the definition you learn in geometry. Because in geometry, you don't have the rectangular system. Okay, you don't have these, positions. And so this definition has similarity to the trig, to the geometry definition about the trig function, but it's also different from it, okay, because the setting is different. So cosecant is going to be r over y, and secant is going to be r over x. Okay, so I'm going to redraw the picture. Okay, because it messed up a little bit, right? So once again, A is the angle measured in standard position. Okay, measuring in standard position, that's the angle A. The input of A, right? And the output for different functions are different ratios. So on the terminal, On the terminal, we choose points arbitrarily. We choose point arbitrarily, but this point cannot be the origin, right? Other than the origin, okay? Other than the origin, okay? Notice this word. So any point you choose, okay? Any point you choose, you might be asking, if I choose different points, am I gonna get the same output, right? Okay, stay tuned, that question will be answered. That question will be answered. So this point has x comma y, right? And the x is going to be the horizontal measurement, and the y is going to be the vertical measurement. Okay, I'm just make a distinction of the color. Okay, so this is x, this is x, this is y, right? And Pythagorean theorem, we can find this is the hypotenuse. This hypotenuse is called r. This hypotenuse is called r. Okay, so r, and this is x, and that is y. And you can see input are angles, right? Input are angles, the output are various ratios. Okay, so the output are ratios. So each function produces one ratio, okay? Exactly one ratio. All of these are functions. Now, we're going to show you the ratio is going to be the same no matter which point you choose. No matter which point you choose, okay? Just so stay tuned, we'll get to that point. Now, so this is the definition. This definition, along with standard position and angle measurement and R reference angle, these are the most important things about trigonometric functions. So we're going to focus on this definition to see what we can discover from this definition. Okay, so now let's first understand this definition. First understand the definition. So I have some examples to show you. Okay, I have some examples to show you. Okay, so first we're going to start with sine. We're going to start with sine. Okay, all right. So from the standard position, okay, we're going to discuss these four cases. Okay, so I'm going to bring standard position ARD. Okay, standard position ARD with us. Okay, standard position ARD with us. Okay, the first case. Okay, so now we're going to do sine first. Sine. Okay, where's sine? Well, we have the sine function somewhere, right? There. Never mind, it's okay. Okay, so we're going to use a definition. Okay, for sine, we will have, in this example, right? Excuse me, in this example, our terminal is in the first quadrant. Okay, our terminal in the first quadrant. So if you look at the function, right? Look at the function definition. Let me bring back the definition of the function right here. Okay, so we have that stage set, and be aware, right? So in this particular example, in the first case, when the terminal is in the first quadrant, what do we get? Right? We know that X is a horizontal measurement, Y is the vertical measurement, right? X is horizontal. Okay, and Y is the vertical, right? And so XY. x comma x, y, and this is R by Pythagorean theorem, Okay, so now sine is y over R, right? The hypotenuse is always positive. Y in the first quadrant is positive. So the sine ratio of y over R in the first quadrant is going to be what? Is going to be positive. Now, what if in the second quadrant? In the second quadrant, x is negative, y is positive, right? So in the second quadrant, sine is still y over R. Y is positive, so sine is also positive in the second quadrant. So by the same token, you can analyze the third quadrant and the fourth quadrant. Okay, so let us try to have a better understanding of the definition. So I have prepared some examples for us to go over. So here, I'm going to take this and the stage set. Okay, I'm going to take all of these and the stage set. Okay, all of these and the stage set. We're going to look at the example we have right here. Okay, I prepared 4 examples. I'm going to do one function at a time. Okay, so the first function we're going to do is sine. And the rule of the function, okay, it produces the output, right? So sine function, that's the rule. See, a function is a rule. This rule produces a ratio. And this ratio is y over R. Okay, so now I would like you guys to follow me, and we're gonna start on that journey. Okay, so this angle, I don't know what that angle is. I know that angle is A. Okay, the terminal is on this line. And I pick arbitrarily a point, 3, 4. This point I pick up arbitrarily, right? 3, 4. So with this point, I can calculate this angle A, okay? And how are we going to write it, right? So here, this is how we're going to write it. Sine of A is equal to the ratio, right? X comma Y. So that's going to be 4, right? Over R. What is R? Right? We need to find out what R is, right? R is X squared plus Y squared equals to R squared. Okay, so what is R? R in this case is equal to, okay, R squared is equal to, well, we just use the formula in the definition, okay? It's a square root of X squared plus Y squared, right? And X is 3, Y is 4, and that's going to be what? The order of operation, right? 3 squared is 9. So 9 plus 16. And then it's going to be square root of what? 25. Square root of 25 is what? 5. So now we got R. So sine of this angle now is what? 4 over 5. You see that? By definition. Okay. This angle that terminates in the first quadrant, you can see sine ratio. Okay, sine value is a ratio. You see the input is angle measured from standard position. The output is 1 ratio. It's 1 ratio. For each angle, there's exactly 1 ratio. Okay, we're going to talk about that uniqueness in later. Okay, so right now we just focus on the application of the definition. Now, let's look at the second one, okay? In the second quadrant, okay? It's still, okay? It's still the definition, but this time the angle is measured and it terminates in the second quadrant. Okay, this time the angle is terminated in the second quadrant. Okay, so I'm going to measure another angle. This angle measured from standard position, which is A, right? This angle is A. How do we figure out the sine of A? Okay, how do we figure out sine of A? Okay, maybe I can put it here, right? We find a point arbitrarily on the terminal. Okay, and then I found this point because I can find any point on the terminal. Therefore, I'm gonna use this point. So sine of A. Maybe I should put it on the top, right, to make it easier for you to see. So sine of A equals to, okay, the x. What is the x, right? So let's understand what is x. Okay, the x is -3. X is -3. What is y? Y is the vertical, right? So this piece is -3, and that piece is a +4. Okay, and how about the radius? How about the r? Okay, what about the r? Okay, so let's first find the r. What is the r? Okay, we can change the order a little bit, right? We don't have to follow the same order. Okay, we're gonna find the r. What is r? R is the square root, right? It's in the definition, x squared plus y squared, right? And what is our x squared? Our x is -3. X is -3. And y is 4, right? So once again, -3 squared is going to be what? It's 9, right? So 9 plus 16, right? -3 times -3 is positive. So that's going to be 20 square root of 25. Square root of 25 is 5. Now sine of A is equals to what? It's y over r. Y is 4. R is what? R is 5. R is 5. You can see in both cases, sign are positive because y is positive in the first quadrant. Okay, in the first quadrant, y is positive. Y is positive, right? That's how sine is positive in the first quadrant and second quadrant. Now let's look at third quadrant. Let's look at third quadrant. Okay, third quadrant. Okay, on the third quadrant, we still apply our definition. Where's our definition? Right, it's right here. You see r equals to square root of x squared plus y squared, right? So in this case, you see we've been consistently using definition. Okay? Don't worry about the tricks, okay? I don't want you guys to worry about those tricks now, okay? You will create your own tricks after you fully understand the definition. So now let's look at this angle. Okay? This angle, which terminates in the third quadrant, okay? It terminates in the third quadrant, right here. Okay, in the third quadrant, let me just move it up right here. Okay, so now on the third quadrant, of course, our input is angle, and angle is applied to the rule of sine, right? So sine of A, right? The output is a ratio. This output is a ratio. The output is y over r. Okay, so the point of our choice, which terminates in the third quadrant. So my angle could be measured like this. Okay. This could be our angle. And that's a terminal. For that terminal, I pick up a point not from the origin, any point other than origin on the terminal. And I pick up this point, -3, -4, -3, -4. Okay, with that, I'm going to find R. But first, we need to understand what is -3, what is -4, right? So -3 is going to be that much. That's -3. And what's -4? This is -4. Okay, this is -4. So this side is -3, and that side is -4. And what is R then? What is R then? R is still the square root of x squared plus y squared. So our x is -3. Our y is -4. And continue the calculation. Okay, -3 squared is 9, -4 squared is 16, and then we get a square root of 25 again, and the square root of 25 is a 5. So now this angle A, okay, this angle A here, okay, sine of A is equals to y over r. What is y? Y is -4. So -4 over r. R is 5. You see, the terminal of the angle that ends in the third quadrant, sine is negative. Sine is negative. Okay. Now, continue. Okay. How about what happened in the fourth quadrant? Okay. So we continue the journey. If I have another angle here, okay. So this angle, how do I measure this angle? Well, I measure this angle still from the standard position. Boom, this angle. I'm going to call this angle A. Okay, this angle A. Now for this angle, and there's a terminal. On that terminal, I choose a point arbitrarily other than the origin. See, I'm citing the definition. A point is chosen on the terminal arbitrarily. Okay, and the point I choose is 3, -4. 3, -4. Okay, with that choice, right? I know what is x, what is y, and what is r. Once again, I know sine is a function, right? Sine function. It produces a ratio, and that ratio is y over r. Okay, y over r. And what is y? This point is x, -4, right? And it tells us what is x. X is a horizontal measurement. Okay, and y is the vertical measurement. Okay, so this piece, the horizontal one is 3, the vertical is -4. Okay, and now I can find my r. R would equals to square root of x squared plus y squared. And our x is 3. Our y is what? -4. We actually don't need this parentheses for 3. Okay, and now once again, we got once again, right, 9 plus 16. And that equals to square root 25. Square root 25 is 5 again, right? So now we can calculate sine of this angle A, which is equals to y over r. Y over r. Y is -4, right? And r is what? R is 5. R is 5. Now let's summarize. Let's summarize from this example, right? What have we learned? Yes, it is an example, right? So let's summarize this. To summarize it, right? For sine function, right? Just for the sine function. By definition, right? We have that stage set, standard position, angle measurement, reference angle, and definition. With that definition, okay, I'm going to summarize for you. All right, so let's look at the summary. We look at the 4 cases, right? So I'm going to have so many rows. Okay, that should be enough, right? The same rule, right? And we measure all the angles, right? I'm going to put these 4 examples in our picture, right? In the first quadrant, right? I encourage you guys to do these summaries, right? Summaries. Second quadrant. Second quadrant. Second quadrant. Okay, third quadrant. Third quadrant. Okay, and fourth quadrant. Last one. Different angles, certainly. Different angles. They're all different angles. Okay, so let me just make it a little bit smaller so hopefully we can hold more things. Okay, you should have notes and pause as you need. And watch this again. This is a single important concept. This is a single important concept, right? All these different angles, all of these different angles, right? By one definition, one definition for sine. Okay, of course, we're going to do cosine. Okay, we're going to do cosine for sure. Sine okay, sine. In this case, right? In this case, in the first quadrant, sine is y over r because y is positive, right? And in the second quadrant, y is positive and y is negative. So you can see the sign of y determines, because r is always positive. So the sign of y determines that sine is going to be positive in the first quadrant, no matter where the terminal in the first quadrant, right? You could have other terminals. Yeah, you could have other terminals. It doesn't matter where, right? Any other terminal, the y is going to be positive. So sine is positive in the first quadrant, positive in the second quadrant, right? Doesn't matter where the terminal. Negative in the third quadrant. Doesn't matter where the terminal. And negative in the fourth quadrant. Doesn't matter where the terminal. As long as it ends in the fourth quadrant, then the ratio, according to the definition, will be what? Will be the same as the sine of y. Okay, you can see this is the power of using definition. All right. So now, what can we say in this summary? Right? So sine of any angle, right? If angle terminal in quadrant what? In quadrant 1, terminal in quadrant 2, terminal in quadrant 3, and terminal in quadrant 4, right? Terminal in quadrant 4. And sine is positive. Is positive, greater than 0, right? Sine is greater than 0. Terminal in the third quadrant, sine A will be negative and sine will be negative. Okay, how about cosine? How about cosine? So let's go about to see cosine. Okay, so it will be the same example. What's the definition of cosine? What will be the definition of cosine? That's right, x over r, right? X over r. So I'm going to clean this up, right? X over r. So I'm going to still adopting all of these, but for cosine. For cosine, okay? So all of these rules are changing for what? For what? For cosine. Cosine is x over r, right? Cosine is x over r. So the rule has changed. The rule has changed. The rule has changed, x over r. So now, how about the sign for cosine? What's the sign for cosine? Yes, shall we do a separate calculation? Let's do it. Let's do it. Apparently, all these 4 has the same r, right? We have calculated, right? So r is in these examples is 5, right? R is 5. No problem, right? Because r is calculated respectively, right? So let me summarize the calculation of r, which is x squared, right? X squared plus y squared, right? Very important, okay? Even though we introduced those definition, but in different situation, in this case, it's 3 squared plus 4 squared, right? In that case, the point is -3, so it's -3 squared plus 4 squared, okay? And this case, right, it's -3, -4, right? We honor that even though the answer is the same, okay? So this is 3, and that's -4. -4 squared, okay? So they all end up to be 5. That's not a problem, right? That's not a problem. Okay, for all of these cases. And next, right? So we just did sine. I wish to put this back in for the r. Insert a row, right? I'm gonna put an r there because the r's calculation are similar. Okay, so I wish to keep that for the sine as well, right? So let's look at for cosine. Cosine x over r, right? It's the first one, right? It's the first one. So cosine value, I'm gonna use a table to calculate this. So we have a comparison, right? So r a known. So and it's x, right? So x is essential, x over r, right? So let's look at the axes when the terminal is ended up in different quadrant, right? In this interval, the x is right here. This is x, right? It's a positive. In the second terminal in the second quadrant, this is x, it's a negative, -3. Third quadrant, x is -3. Fourth quadrant, x is what? +3. And x over r, the sign is determined by x, right? So cosine A, right? So whatever angle we end up, right? So this angle A, for example. Okay, so this angle A, right? And this other angle A, right? Or this angle A, right? And they're different angles, and this A. Okay. All right. So for these different A's, they determine it in different quadrant. In the first quadrant, it just equals to x over r. X is 3, which is 3. So 3 over 5. 3 over 5. The second one, cosine, we take the angle as input, and the output is a ratio, right? In this case, cosine, of an angle that terminates in the second quadrant, the x is a -3, so it's a -3 over 5, right? You can write it as -3 over 5. It doesn't matter which way you write it. Either way is fine. Now, the next one, cosine A equals to, cosine A is equals to, right? Still x over r. What is x? X is negative, right? So it's going to be the same answer. It's going to be the same answer. And the last one in the last quadrant, and that's going to be x is now positive, right? So this time is 3 over 5. 3 over 5. Okay. Now, look at this, right? Terminal terminates in different quadrant. Okay. Cosine terminate for angles terminate in the first quadrant. Cosine of that angle is positive. Terminates in the second quadrant. Cosine A is going to be negative. In the third quadrant, cosine A is going to be negative. The fourth quadrant, cosine A is positive. Positive. So you can see it's determined, the sign of cosine is determined by the coordinates x. Okay, the horizontal terminal coordinate x, right? And for next time, okay, in the next lesson, I think this is probably, I don't want to be too long. We are going to look at a tangent and cotangent from definition, and of course, secant and cosecant. Okay, I will see you guys in the next lesson. Thank you for watching.